All right, guys. If I sound a little funny, I'm fighting a cold, and I am sorry for that. We are going to start by studying linear functions in the coordinate plane, and it's important to review what we mean by the coordinate plane. We take two lines, one horizontal, one vertical. It is traditional to label the horizontal line the x-axis and the vertical line the y-axis. We then set out on each axis at equal intervals some scale. Generally, that scale is 1 unit, but the scale can change, and if it does change, you should let the person know by labeling your scale. If you don't label your scale, then I'm going to assume each mark means 1 unit. You do need to always label your axes. While it's traditional for the horizontal axis to be x and the vertical axis to be y, they don't have to be x and y, they can be other things. So please always label x and y. When we list a point, we list it as what is called an ordered pair. And what goes first is the x coordinate, and what goes second is the y coordinate. I know this is review, but it never hurts to make sure we know what we're talking about. When x is positive, we move from this point right here, often called the origin because the coordinates are 0, 0, 0x units, 0y units. When x is positive, we move to the right. When y is positive, we move up. When x is negative, we move to the left. When y is negative, we move down. So some of your homework is to figure out what are the coordinates of point A. And if it was a better scale, you might see, little lines here that go through to make it easier for you to see the coordinates of A. Hopefully you can see that the coordinates of A, moving from the origin, are over to the right 2 and up 3. So A would be the coordinates 2, 3. It's also important to remember in the coordinate plane the quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and lastly, this is quadrant 4. It's one of the few areas where you'll use Roman numerals, but you don't have to. In quadrant 1, both x and y are both positive numbers. In quadrant 2, x is negative, but y is positive. In quadrant 3, x is negative and y is negative. And lastly, in quadrant 4, x is positive and y is negative. Okay, the other thing that we're going to be working on in this first unit is just getting in the habit of creating a chart of x and y values to plot functions and see how they look. You may have studied linear functions in another algebra class, and I want you to hold off on all the things you know about linear functions, and instead just take an equation like this: y equals 1/2 x minus 3. And you may know a lot of ways to graph this, but right now what I want you to do is I want you to create a chart of x and y values. And before we just start listing values of x here, I want you to think critically about what would be nice values of x. A really good value is 0. And you might be wondering, why am I putting 0 in the middle of my chart? And that's because I want you to try a few negative values and a few positive values. So I like 0 to be in the middle of negative and positive values. Now another thing that you might think is -1 and +1 would be good values. They're easy values, but they're not necessarily good values for this particular function. And the reason for that is if you plug in 1 right now, so if you say x equals 1, then you get that y is equal to 1/2 minus 3. And now you get y is equal to -5/2. And that's not always an easy number to graph. So instead, what I'm going to try is I'm going to try -2, and I'm going to try -4, and I'm going to try +2, and I'm going to try +4. By choosing even values for x, when I multiply by 1/2, I'm going to get some really nice values for y. So what I'd like you to do after you think critically about the x values you want to use, and I want you to work on getting about 5 x values. 0 I think you should always try, but then 2 negative values, 2 positive values in addition to 0. Plug in each value of x into this equation and solve for y. So let me cross this out. So we've got x equals -4. When x is equal to -4, y is equal to 1/2 times -4 minus 3. So notice the opportunity this allows us to practice some of those things that we did in the first unit. A positive times a negative is a negative. 2 goes into 4 2 times. I get -2. Then I subtract 3 and I get -5. Pause the video now and take the opportunity when you pause the video to fill out the rest of this table. Unpause the video when you think you've got all of them. Okay, if you did this correctly, you should have gotten that you get -4 here, -3 here, -2 here, and -1 here. If you need to see any of those worked out, let me know, but I will do the last one for you. Y equals 1/2 times 4 minus 3. 1/2 times 4 is 2. 2 minus 3 is -1. Good? Once you get this chart complete, now what I want you to do is go to the coordinate plane, draw an xy axis, and plot those 5 ordered pairs, those 5 coordinates. So we have -4, -5. That's in the third quadrant here. We have -2, -4. We have 0, -3. We have 2, -2. That's the fourth quadrant. And we have 4, -1. And now we've got this nice straight line through those 5 points. Always put arrows at the end of your lines. You should probably have them on the axes, but I don't care as much on the axes. Label the x-axis, label the y-axis. What this line represents every single possible xy pair that makes this statement true. Now there's an infinite number of xy pairs that make the statement true, and an infinite number of pairs that makes the statement not true. Take the point 0, 0. It's not on the line. That means if I plug in 0 for x, I will not get 0 for y. Right? And you already know that. If you plug in 0 for x, you get -3. So 0, 0 is not on this line, meaning it's not a value of x and y that makes this statement true. But take the problem I did at the very beginning. When x equals 1, I got -2.5, which is right here. That point is on the line. Even though I didn't graph it in my chart, I can see it here on the graph of this line. It is a valid point. It's just not an easy one to graph. Here's 1 and -2.5. I'd like to show you a tool that is available on every MacBook computer that you have with your school computer. If you go to Finder and you do a spotlight search for a program called Grapher, you'll see it pops up with this option of you want to create a new graph. Let's just do two-dimensional graph and default and hit choose. And then what you can do is you can graph anything y equals in terms of x. So I'm going to graph that function we just did, 1/2 x minus 3. Now if I grab the little hand tool, I can move around and I can see all of the possible solutions here to y equals 1/2 x minus 3. You can see this goes on forever. I can zoom out and you could see, all the possible values. All the possible values that make this statement true. Now I'm zooming back in here. I want to look at a point way out here, 100 comma something. So if I do a little math here, let's see. X equals 100. y is equal to half of 100 minus 3, that's 50, minus 3, that's 47. So the point 100, comma 47 is on the graph, or should be on the graph based on my algebra skills. So write that work down if you need. I'm going to clear it off so I can flip back to this other application. So if you see here x equals a 100, you can kind of see that, yeah, that looks like it's about 47. I think you can actually check that by some stuff up here that I haven't played enough around with. I think you can do a valuation and plug in 100, and you can see right there y is equal to 47. Now don't worry about these other options yet, but right now x equals 100, y equals 47. We could go back to that value of 1, and you see the negative 5 halves that we come up with. You can see it right down there. Pretty powerful tool available to you to check your work while you're using your MacBook. One last problem I'd like to show you is when the equation is not as easy as y equals 1/2 x minus 3. What if we had something like 2x plus 3y equals 12? Couple things we can do here. We can simply work with this the way that it is, and we can take values of x and plug them in and solve for y. Or we can start using something we practiced last unit, which is solving this equation for the variable y. I'm going to do it that second way. I'm going to take this entire equation and I'm going to isolate y. So remember, to isolate y, I want to see what am I doing to y and how do I undo those operations. You want to go in the reverse order of operations. So notice I'm adding a 2x to 3y, so my first step is to subtract 2x, excuse me. So when I do that, I get 3y equals negative 2x plus 12. Now I want to get rid of multiplying by 3. So I'm going to divide this by 3, but remember when you multiply or divide, you have to multiply and divide every number. When you do that, 3y divided by 3 gives you y. Negative 2x divided by 3 just gives you negative 2x divided by 3. Leave it that way and you're good to go. Plus 12 divided by 3 is 4. Now when we make our chart, let's think about values that would be good for x. I'm thinking any value of x that's divisible by 3 would be good. Because we're dividing by 3, I'm going to choose negative 6, negative 3, 0, 3, and 6. That way, my math will work out really nicely. I plug in an x equals negative 6 into this equation, and I get y equals negative 2 times negative 6 divided by 3 plus 4. A negative times a negative is a positive, so I get positive 12 divided by 3, that's 4. I get 4 plus 4, which is 8. Pause the video, go through this, and fill out the rest of the chart. Okay, if you filled out the chart correctly, you should have gotten that this was a 6, that this was a 4, that this was a 2, and this was a 0. Now when you go to graph this line, go back 6 and up 8. That point would be right up here. Go back 3 and up 6. Over 0 and up 4. Over 3 and up 2. Over 6 and up 0. Label your x-axis, label your y-axis. Connect the points with a solid line. Sorry, I'm doing this on a tablet. It's hard to do. You could always use a ruler, but as long as I can see these values here, you're good to go. All right, good luck with the classwork. Sorry I'm not there today. Do your best. Turn your work into Miss Bosca or Ms. Eisman, whoever your teacher is. Have a good day. See you soon. Peace.